Okay, I'm going to get started, if that's okay. Welcome back, everybody. Welcome back to the people online. We are now going into our second session. And our second session is on the pollution that happens across that land-sea interface. So we will have first a talk by Dr. Saša Marcinek, who's a postdoctoral researcher at the Ruda Bokovic Institute in Croatia. Please pronounce it correctly for me. I'm trying my best, but Saša will speak about her research on the trace element contaminants, including the impact of climate change impacts, and the impact of climate change on their transport, fate, and biogeochemistry. So we're going very much from the policy side to the hard science. Floor is yours. Oh, I will press the button. Let's see.
Hi. First, I want to say that I'm very glad to be here, and thanks. Okay. Thanks to European Marine Board for inviting me. My name is Saša Marcinek, and as Sheila almost said, I'm from Ruđer Bošković Institute from Croatia. Currently also postdoctoral researcher at Institute of Marine Sciences of Andalusia in Spain, but financed by Croatian Science Foundation. So today's topic is pollutants of concern and their pathways. I will talk specifically about trace metals as contaminants. I will introduce their sources, cycles, but will focus on future implications of climate change. Natural source of trace metal is lithosphere, and they can end up into the seawater by volcanic and hydrothermal activities, through geological weathering, erosion, or leaching from soils and plants, through rivers, groundwaters, or atmospheric deposition. In addition to these natural sources, there is a number of anthropogenic ones, major one being mining and smelting activities, but also industrial effluents, transportation, agriculture, and other urban activities. So we are facing increasing industrial and population growth, which is bringing unprecedented demand for metals, and they are being exponentially produced and inevitably released into the environment, with aquatic environments being final destination for most of these effluents. And beside increase in volume, there is also increase in variety of metals that are being produced and introduced into the environment. One example are these rare earth elements, which are now considered technology critical elements, and they are critical for development of new technologies like energy efficiency, renewable energy, and technology. And they are now considered from a sea point of view, emerging contaminants of substantial concern. So here we are going again from society, economy, nature, like David highlighted, and going back full circle. So trace metals can be categorized as essential or non-essential, with non-essential having no known physical, logical role known to us. And they can be very toxic, like mercury or lead. But it is important to know that those makes the poison. So them just being present in the environment doesn't mean they're in toxic concentrations. And also these essential elements can be toxic in elevated concentrations. And some of them, like cadmium or copper, have this very narrow range between scarcity and toxicity. However, another important thing to note is that total metal concentration doesn't say much about its effects and reactivity in the environment. And keyword here is speciation, which is distribution of metal between its chemical species, of which free metal ion is considered most bioavailable and the most toxic. And on the other hand, organic ligands in most cases reduce this bioavailable concentration and reduce its toxicity. This is, for example, reason why copper in coastal waters, although it can be in relatively high concentrations, is rarely found toxic, because coastal waters are also abundant with these organic ligands that are reducing its free concentration and reducing its toxicity. When they end up in the marine environment, there is a number of physical, geological, chemical, biological factors that are influencing their behavior, especially in dynamic coastal environments. I won't go into details. I just wanted to illustrate it here, the number and complexity of all of these interactions. For example, in estuarine environments, this salinity gradient is main governing factor, in which metals can be removed through flocculation and sedimentation or added by desorption from particles. So now we are facing climate changes, which are adding another layer, new dimensions to these trace metal cycles. And in next few slides, I will present you some insights from recent paper. This paper was a result of efforts of GESAMP group, which is UN Advisory Group on Marine Environmental Protection. So climate change drivers, primary like ocean warming, ocean acidification, and secondary drivers like changes in salinity, changes in oxygen levels, they are impacting trace metals in three ways: by impacting sources and pathways, by impacting their cycles and reactivity, and also by impacting biological response to these contaminants. So I will start with a hydrological cycle, which is changing in response to warming climate. So we can expect increasing precipitations in northern latitudes, which will also be reflected in increased river discharge and runoff. On the other hand, we have areas like Mediterranean, which are expected to see worsening aridity, but also increase in seasonality. So we can expect more likelihoods of floods, droughts, wildfires, all affecting trace metals in the sea. So as riverine discharges increase, this will also increase metal fluxes. This study in Eastern Iceland was 40-year survey. So they show that there is dilution with riverine and glacial water, but all metal fluxes increased with increase in riverine discharge, and this was specifically 6 to 18% per degree Celsius. Submarine groundwater discharge, another important source of trace metals. This will be affected trace metal mobility, both in response to increased precipitation and decreased precipitation. First, by increased groundwater levels and amplitudes, and second, by seawater intrusions into the aquifers, changing aquifer chemistry and mobilizing metals that were locked there for centuries. Sediments are sink of metals in marine environment, but it is not final sink because they can be redistributed in the water column through different physical processes like turbulent mixing, bioturbation, human activities like dredging, or chemical changes in sediment. And climate changes will affect this through sea level rise and extreme weather events by redistributing more floods or erosion, by changing chemistry of sediments, or by physically disrupting sediments. So this could also transport metals and transfer them further from the contamination site. Polar regions are especially subjected to climate changes. And in addition to these sources, we also have glacier melting, ice melting, glacier erosion, permafrost melting, all adding to metal fluxes and also disturbing environmental dynamics. Permafrost is of special concern because it holds vast metal reserves, like twice as global mercury reserves. And these are all threatened to be released as permafrost melts. Now, how climate change impact the biochemical cycles. As I said, the keyword here is speciation. And speciation will be mostly affected by ocean acidification. And this will mostly affect metals that are carbonate complex or in hydroxides by increasing their free metal ion, which is their most toxic species. These are, for example, iron, copper, or lead. However, as I also said, organic speciation is important here, and this is less experimentally studied, and it can be less reliable modeled. Some studies show, these are some examples for copper, that acidification increases its free metal ion and decreases complexation due to competition between hydrogen and calcium ions for binding sites. But other research shows that changes in composition and concentration of organic matter are of more importance than changes in pH. And finally, impacts on biological responses. So climate change can affect the biological organism's physiology, which can influence how they react with trace metals. Like they can increase metabolic and energy demand, which can increase food consumption or decrease their tolerance to metal stress. And there is many research conducted, and there is no unified conclusion because results differ between climate change drivers, between trace metal, between species, life stage of the species, with early life stages being most vulnerable. And this goes from, for example, ocean acidification having no effect on bioaccumulation, but having substantial effects on biological responses. On the other species, there is increase in bioaccumulation, but acidification is decreasing toxicity. So there is also a combination of drivers. Mostly studied are ocean acidification and ocean warming. This is a review on mercury toxicity. These combinations showed both synergistic and sometimes antagonistic combinations. And also results differed between species and also between geographical regions, with some species from temperate and tropical regions responding differently. And also there are some signs for species adaptation to gradual changes in climate. So in summary, anthropogenic emissions of trace metals are increasing both in volume and variety. Toxicity of trace metals depends on their chemical form, how organisms interact with them, and environmental conditions that are influencing exposure. Their distribution and cycling is governed by various processes in the environment, and climate change is adding to this complexity by altering sources, transport cycles, and also biological responses to combined stressors. And understanding these interactions is essential to manage trace metal impacts on coastal ecosystems. Thank you for your attention.
Maybe you can stay there, and if we have any questions in the room or online. Okay, Torsten has a question. He gets to have a question eventually. Sorry, Torsten.
Thank you very much for this presentation, which was made. It explains the whole science of trace metals. But what I don't know now is what should we do now, let's say, in terms of action, in terms of policy measures, and so what's the urgency? Can you detect any recommendations, or did you use any recommendations from presented?
Well, recommendations update research so we can see more effects on biology and speciation models. Also, what I'm doing, I'm focusing on these technology critical elements, which we don't not know much about. So ecotoxicology experiments with rare earth elements on all species levels and things like that. And what's policy, I'm not sure.
Yeah, you know,
there is a lot of sides that we can attack this problem.
I don't want to put you too much on the spot, but I mean, if we had to make choices, should we really make sure that inflow from rivers is tidied up, or is bottom trawling, avoiding that to stop remobilization of sediments. And so what is the big culprit of trace metal contamination?
So society, economy, nature. So stopping maybe pollution, not stopping, reducing is a keyword. Yeah, and from a land point of view, like more efforts into wastewater treatments, like for example, these platinum and gadolinium medical complexes are escaping water treatments, or agriculture effluents, or waste management, or adaptation of the coast, like preserving wetlands and seagrass beds to stop erosion and stop spreading of trace metals.
Thanks. I think that's a. I think we're out of time. So, did you want to? Yeah, I think. All right. Thank you very much. We will still have a panel discussion, so you can hold your questions for later. Our next.
All right, so our next speaker is Efthymios Lytras, who's the Deputy Director of Corporate Strategy and Innovation at EADAP, the Athens Water Supply and Sewerage Company in Greece, who might be talking a little bit about what you proposed just there. He is also a partner on the Mission Ocean project called Remediation that we are participating in. And the project of that is to de-stress the Mediterranean Sea from chemical pollution by testing microalgae remediation solutions in existing wastewater treatment plants. Whew. Okay, I think I just need to click on there and then your talk should come up.
Thank you very much for the invitation and for giving me the opportunity to talk about ADAP strategy regarding management of water and wastewater. So Athens is an unusual case of water wastewater management because it is a heavily populated city of more than 4.5 million inhabitants in an arid area without rivers or lakes that can provide water. So in the beginning, in the 30s, we constructed an artificial reservoir in Marathon that is 25 kilometers away of the city. Then after war, we connected to this natural lake, which is 100 kilometers away of the city. Then in the 80s, we moved even forward to this artificial lake that is 200 kilometers away of Athens. And finally, now we are far enough at 270 kilometers away of Athens to get fresh water. So this is a quite large drainage basin that is subject to potential pollution. So how to tackle this pollution? First of all, prevention. There are protection zones around the reservoirs. By law, no industrial or agricultural activities are allowed around the reservoirs since the early 80s. That means that there are no potentially harmful influence in the lakes. There may be airborne pollutants, but this should be very, very small quantities comparing to the lake's capacity. Second is monitoring and doing quality control. So we conduct extensive samplings and tests that assure excellent water quality and also treated wastewater quality. PFAs are added to the QC scheme in water since 2018. We have very good laboratories that operate state-of-the-art analytical equipment and deploy all the time new analytical techniques. And we cooperate with one of the best labs that are specialized in micropollutants in the National University of Athens. This is this one at the end. And you can see here the instrumentation capacity of this lab. This is quite a good slide because it underlines also how expensive and complex is to test and monitor all these new emerging pollutants. Then adaptation, upgrading our infrastructure. The larger wastewater treatment plant of Athens that lies on Psyttalia Island and treats more than 800,000 cubic meters of wastewater per day is going to be, let's say, facelifted to meet the requirements of the new Urban Water Treatment Directive, and also we're going to try to get advantage of better energy management, water reuse. And among all this, there will be a new quaternary treatment in order to remove micropollutants. In addition, a new wastewater treatment plant in Rafina that is 135,000 to 225,000 population equivalent. It's first and second stage. That this is scheduled to operate for 2030, will include from the first day of operation membranes in its treatment scheme. Eliminate discharge and reuse. The best way to not having polluted discharges is not having discharges at all. So we are trying to promote water reuse in Athens. Industrial reuse, there is one of our wastewater treatment plants in Triasio area. You can see it in the circle on the left that is going to direct 100% of its effluent to a petroleum refinery that is on the right. So this is a distance of 4 kilometers. We are already working on that, and we hope that in 1 year, more or less, we will have this works finalized. So no wastewater at all will be directed to the sea. Agricultural reuse. We are constructing 4 new wastewater treatment plants in East Attica, and all of these will reuse effluents for agricultural reuse. There is a master plan for that is ready and is updating all the time until the moment that these treatment plants will operate. And you can see 2 examples that this in green are the irrigation areas that will be irrigated when the treatment plants start operating. And finally, urban reuse, sewer mining in the urban web. This is something quite innovative for us. We have 2 units already in operation, and we're planning to have more. So this is, as you can see down the sewer pipeline, we install a pumping station that is underground, so nobody sees anything. And then we pump raw wastewater to a buffer tank that is also underground. And then we drive this wastewater to a small, let's say, very, very pocket wastewater treatment plant that operates with MBR. We disinfect to the storage tank, and then we can irrigate the green areas around the city or also recharge the aquifer. This is a very good solution because we do not have to transfer treated wastewater from the main treatment plant around the city. And finally, R&D, host and support innovative solutions. We are partners in a lot of funding projects. The 5 on the left, environment, remediation to drink, heavy MOFs, and upwater, are projects that deal with innovative treatment technologies, and also Impetus and Theseus are projects that deal with reuse and circular economy innovations. So in a nutshell, our strategy is to prevent, to monitor, to adapt, to eliminate effluents, and research. Thank you very much for your attention.
Thank you very much. I think we're going to have a panel discussion now, so maybe you can take position in the chair. I don't know if there's a clarification question, but maybe we can just have the panel discussion. And Saša can also come up. I'm going to sit on the first chair, so you guys can distribute yourselves equally there on the other chairs. We also have two more speakers. I hope we have two more speakers. I'm not really sure that Adriana is here. Have we? Ah, there she is. Thank you. So please do join us. We have Detlef Schulz-Buhl, who's from the Leipzig Institute for Baltic Sea Research, Warnemünde in Germany. He has expertise in organic pollutants and monitoring. And Adriana Constantinescu from GeoEcomar in Romania and from the Danubius Research Infrastructures, who has expertise in water and sediment fluxes. For the guys on the chairs there is some microphones that you would be able to use. And yeah, you don't need to do anything. It should work fine. And the online attendants, remember, you can ask questions in the Q&A and for the people in the room. So I think we'll start by giving our two new panelists, or maybe I don't need to look over my glasses at you guys, giving it a moment to explain your expertise. So maybe Adriana, can you start? Yes. Is it working? Yeah, just,
I think now.
yeah, there we go. Perfect.
Should I
Maybe
introduce myself?
just introduce yourself. Yeah.
My name is Adriana Constantinescu. I'm a marine geologist, and I work at the Romanian Institute for Marine Geology and Geoecology. I'm also involved in the development of Danubius research infrastructure, and I'm going to tell you a little bit about it. So.
Good. And Detlef, maybe you want to introduce yourself as well?
Was on?
Yes,
Yes,
it just
okay,
takes
thanks.
a moment.
So yes, my name is Detlef Schulz-Buhl. I'm from the Baltic Sea Research Institute in Warnemünde. So I'm a main chemist, a little bit exotic, and an analytical chemist, even more exotic, and a marine analytical chemist, very exotic. So I worked on organic pollutants for almost 40 years during my whole career. And I ended up in the Baltic Sea. So I came from the open ocean, and I would say some example from my beginning on. I worked on PCBs and DDTs. So you may remember these compounds, very useful industrial chemicals. So we need them during that time. And they were produced in the 60s and 70s. And 20 years later, we came in and find them in the marine environment and say, oh, they are very toxic. Took 10 years to research, to have the pathways, the toxicity and the impacts, and then another 20 years to ban them. So at all, we need 40 years to get the knowledge from the scientists to the regulation. And my learning from this is resist the beginnings. So that's was my first statement for today.
Thank you. Maybe Adriana, maybe you can actually tell us about Danubius, what makes it so impactful for the management at the land-sea interface.
Yes.
I was asking Adriana.
So Danubius RI is the International Center for Advanced Studies on River Sea Systems. It's a pan-European research infrastructure that is being developed at the moment in several countries around Europe. Its vision is to achieve healthy river sea systems and to advance their sustainable use in order to live within planet's limits by 2050. Our approach is to look at the system from source to sink. And land-sea interface areas are part of the systems, and due to their nature, they have very complex dynamics and phenomena. Danubius RI provides 4 nodes, one for observation, one for analysis, one for modeling, and one for social economic impact. And natural laboratories that we call super sites. Some of them are lens interface areas. And this is where we carry on most of our studies. But of course, the services of Danubius RI will be available in any reverse systems. So our goals are to overcome the current fragmentation of science, knowledge, data, and management in reverse systems by integrating spatial, temporal, disciplinary, and sectorial thinking, to provide solutions to environmental and societal risks from climate change, and to resolve problems arising from human impacts on reverse systems by using a multi and interdisciplinary perspective from source to sea. A set of comments will ensure that the parameters and methods we use are comparable across the systems.
Thanks, thanks. Maybe Detlef, I can come back to you again and say, I think there's a question here. How do we, how able are we really to detect different organic pollutants in the coastal waters by now? And where are we still struggling?
So I think you heard from your nice talk how complicated is the analytical part to measure these organics, especially in seawater. It's a very, very complex matrix to measure it. So we are not able to measure all contaminants at the moment. And this is the problem of the concentration. So concentration of these compounds going down to femtogram per liter. Do you know what a femtogram per liter?
I do not.
It's 10 minus exponent minus 15 gram. And we are able to measure these low concentrations. So that means it's about 1 kilogram in the Lake Constance. And then you take out a liter and you see, is there something in? Is that important? Yes, it is, because on the other way, with these marine food chain concentration, you go back up to higher levels until they have toxic effects. So in seawater or in water, it's very complicated. So what we should do, we should go to the wastewater treatment plants where they have the input sources, the higher concentrations, and try to find the problematic new contaminants of concern there. We know about all the old stuff, the Stockholm 12 components. We know very well. We know how they behave. We can measure it. We know a few new contaminants like PFAS you heard about, or brominated flame retards. There's a lot of research. But for the very new ones, glyphosate, for instance, or UV filters, we didn't know where they are, in what concentrations we can find them. Only a few examples exist in the literature. And these are the compounds we have to concentrate on.
Yeah. Maybe, Saša, I'll come to you. Maybe you need to use the, it should still be on, yeah. My question is really, we've heard that there's a lot of component chemicals out there that we don't really necessarily know much about. What do we know about the impact of climate change on the things that we know already? Do we know enough? Do we understand well how climate change might impact the speciation and the impacts that it might have?
So speciation is in general, without climate change, still not very well understood for many metals. So yeah, especially in response to climate change, we can not grasp it yet to predict some accurate assessments. And also ecotoxicological effects. We need more holistic studies on all trophic levels, all life stages, different locations, to see possible adaptations to both contaminants and climate change effects.
Yeah, also because I think climate change will impact, say, the growth of the different species as well, which will also change how they take these compounds up as well.
It's even more important than trace metal concentration and bioavailability is this how organisms will react to climate change, and because of that to trace metals.
Yeah. And maybe I'll come to you, Efthymios. And given that we're talking about climate change here, how do you think climate change will impact your ability to treat wastewater in the future? And you know, how are you guys adapting to what you think is coming down the line?
Wastewater treatment is very, very much energy consuming. So as long as the climate change needs more energy requirements, will also affect us a lot. The other parameter is the water demand, especially in my country and in the other countries of the south of Europe. Climate change means less rainfall and higher temperature. So more energy, more water demand from people, and then more wastewater volume. So again, more energy demand.
Yeah.
So it's quite difficult to work on that. We are trying to go as much green energy oriented as possible. But again, this is not very easy, as we all know at the moment. Even if Greece has a lot of sun and a lot of wind in some areas and can produce green energy, again, without infrastructure for storage, for large quantities of energy storage, it does not solve the problem that much.
Yeah, and maybe I'll have a follow-on question, because my mind is working on that. You know, there's also the possibility that you'd have a lot more water running off. You know, lots more floods. We seem to be having lots of those. Do you think that will also impact how well you can actually do your job in the near future?
We do not have floods at all.
Yet.
Unfortunately.
Yet.
We have very, very few in some parts of Greece, but mostly we have a water shortage.
But do you know in the rest of the wastewater treatment world how they deal with that? Because I know in some parts it's really hard for them.
Yes, so something that we differentiate from other large cities, and I'm talking about ADAP and Athens at the moment, not for the whole Greece, but we are half of Greek population, is that we have separate networks of rainfall and sewage. So we are not affected by
that's very
floods
sensible.
as some other big cities in Europe do.
Yeah. Okay. And then maybe I'll go back to you, Adriana, and ask, you know, talking about river runoff and the Danubius RI, how have you been able to impact to measure the impacts of you know, pollution in the rivers, for instance, both on land and in the river water and maybe into the coastal zone? Is it something that you guys were involved in indoors? Did you do that kind of measurements?
Yeah, so
Should be on.
yes,
Yeah.
I think it's on. So Danubius RI, first of all, this is a research infrastructure, so its legacy will be very long from now on. One of our research priorities is on on nutrients and pollutants, and this is where we want to understand and quantify both singular and combined effects of nutrients and pollutants in water and sediment, to establish critical thresholds in support of healthy river sea systems. So, for example, there are new contaminant classes that you may be aware of, like pharmaceuticals, drugs, caffeine, and microplastics, which are getting more and more importance nowadays. These may be easier to quantify. Sometimes the historical pollution is harder to quantify. And we applied some of these principles in a research project, which is the Black Sea Doors project. So its legacy, it's going to be shorter for sure. It's coming to an end this year, the project. There are two studies which I think I should mention here for the Black Sea. One, it's on floating marine litter. So it's one of the first few studies done in the Black Sea. So the authors of the paper, which was published 2 years ago, they looked at the influence of rivers coming to the Black Sea, like the Danube and the Ukrainian rivers, the cyclonic circulation in the Black Sea, and they were able to determine which areas are the most impacted. And another study that I want to mention is the effect, you may be aware of the dam, which was destroyed, bombarded by the Russian army in Ukraine, Kakova, I think it's called. And there's a study which was published this year that looked at the effect of the flood wave which was created from the dam and its effect on the northwestern Black Sea. So they found that this plume, which had high concentrations of suspended solids and chlorophyll and so on, and it was 50 times the actual concentrations in the Black Sea. So the impact was quite important, and it created a algal bloom that lasted for 20 days around the shores of the Black Sea.
Yeah. Okay. A reminder to the people in the room, if you have questions, do raise your hand. And if people online also, I see we already have some questions. Maybe we can go, sorry, we need one of the, yes, we need to share now. I have some more questions, but I think it's nicer if we have the questions from the room. Please reminder to say who you are.
Yes, okay, thank you. I am Pablo Abonza from Spanish Institute of Oceanography. And I would like, well, in the European Union, we have this Water Framework Directive and Marine Strategy Framework Directive since more than 15 years ago. So how is your assessment of the situation in relation to pollutants? Are we in good progress, or how do you see the situation? We are improving significantly in relation to pollutants, or yeah?
I don't know, who did you want to answer that question? Because it's not, maybe you'll have a go, Detlef. Okay.
So yeah, we have the same for the Baltic Sea, of course. And yes, we did better than in the past, but we have to think for the new things. So Water Framework Directive is a good way. It's costly, so we are not at the end. In the Baltic, we have a Baltic Sea Action Plan, and we didn't reach the goals at the moment. So everything needs more time than calculated, but it's a good way to go this further. But we can't stop with the Water Framework Directive.
Yeah, I think my understanding of these directives are they put out to get us to get better, good environmental status, good, good environment. I don't know what the Water Framework Directive, it has a different acronym. But I think it's quite clear that we won't get there in the 5 or 10 years of one cycle of this. We have to keep on improving that, I think, is what I understand from that. I think Fiona was first and then Cosimo.
Thank you very much. Like, all very interesting, particularly the Black Sea, I think, and the implications of the dam. But my question is for Efthymios. So, you showed this move and this drive to access reservoirs further and further from Athens, and there's the increased demand for water and energy. But is there like community competition? Like, are there people resistant to you getting access to that water further and further for what is effectively to feed your capital city? We've an issue in Ireland with wanting to access one of our big rivers to support the Dublin water system, and there's a lot of pushback to that. Is that something you see, or it's not an issue, or?
Please repeat, because
Yes. You showed the slide about accessing the reservoirs further and further from Athens for fresh water. But is there resistance from communities?
Yeah, so she's saying that you're using water reservoirs further and further away from Athens for using water, and is there some resistance from communities to using it? do they know? I think is the question. Yeah. It should, yeah.
I could show again the map, but it doesn't matter so much. The large reservoirs that have been constructed the last years are on the mountains. So there are very few population and too much water for them. We're not taking water from anyone to drive it to Athens, but it's the only solution. There's no other solution at the moment, because we're talking about 1.3 million cubic meters per day that we need for the city of Athens and the environs. It's too much water. What we try, and can I take advantage to say something?
Yeah.
Yes. What we try is to promote a lot of water reuse. The problems that we face here is that there may be legislation, there is regulation, the European regulation for reuse for irrigation, and there is a national legislation in Greece for urban water reuse, but this is not obligatory. And since reused, reclaimed water is more expensive because it needs more steps of treatment, then nobody is willing to pay more to get reclaimed water, while there's the option to pay less and get fresh water. So what would be good to consider would be that for the European Union to try to make this obligatory for some cases, like irrigation.
Yeah.
To oblige people to get wastewater if there is a possibility.
Yeah.
If there is a network nearby, and to oblige also the water and wastewater treatment companies to construct these networks, and also to have some, let's say, funding schemes or whatever, so that the final user will pay less than fresh water.
Yeah. Yeah.
And
Or maybe you just need to make the fresh water more expensive.
yes, this
That
is
would be
true.
the easiest way to
Yes,
do it.
This is definitely the easiest way, but don't forget, we all should not forget that water is essential for
Yeah,
life.
yeah,
So
yeah.
it cannot be like iPhones.
Yeah,
So
yeah.
I believe that water should have a low price that is accessible to anyone, and find mechanisms to promote water reuse, but real mechanisms, not only something generic that can be followed or not, etc.
Yeah,
etc.
yeah. I think we had Cosimo first, and then Jill, and then at the back. Do we have any questions online? No.
Thank you.
Cosimo, introduce yourself, please.
Yeah, that's Cosimo Sodidoro from Italy, from the Italian Center of Oceanography. And my question is about your vision for the outlook for the future. I mean, we keep talking about transformative changes, and sometimes I think that this pollution problem is a very tough challenge for these transformative challenges. You know? I mean, as you were saying, once upon a time, we just had heavy metals. And then we start to get organic pollutant, PCB that you name, DDT, and now we get this pollutant of emerging pollutant, emerging concern. We have this medicine, drugs, flame retardant, graphens, everything. And we have a list which is a never-ending list of new pollutant. We do not know if they are there because, as you know better than me, you detect them if you look for them. But we do not look for everything. But whenever we look for something, we find it, wherever. Different concentration, but we got them. So as you were saying before, one possibility would be to stop putting pollutant into the environment. But let's think about painkiller. When you feel for some pain, maybe you are not so friendly about the environment, you just want the painkiller. And the same for many other compounds that we keep using. And the wastewater treatment or whatever, I think that they cannot be that efficient to intercept everything. So having said that, which is the pessimistic view, I came to you like very often citizens came to me, ask, so is there any hope for a realistic solution in, let's say, 50 years to achieve this zero pollution goal or something like that? Or are we talking about something that's too much harder for us?
I don't know who the question is for, Cosimo. Everybody? Yeah. I think there should be 2 microphones there. Do we not have another one? Yeah. Maybe we can share between 2 and 2. Yeah.
So I think you are right. It's a never-ending story. But what we can do, we can be always on the best technique, use the best technique we have. And as you said and showed, the UV filters include in the wastewater treatment. This is one way to reduce the organics a lot. And we should go this way. And then in 100 or 15 years, we will have another problems. But I think we get the technology to get them out of the water. Before they entered into the water cycle of the sea, there is a place we have to be active. And yes, we need these compounds, and we need also, for instance, UV filters, but we can give advice to the people, don't use UV filters, don't use sun cream, and jump in the water a minute later. It's crazy. We had a study and show how this increases over a day. So you can do something. You can't reduce it to zero, never. But you can do something to reduce the concentrations.
I think next was Jill. There, yeah. You two should have it between the 2 of you. There. Jill?
Yeah, thank you. So I'm Gilles Lericollet again. I have a question for Efthymios. So even if you are most familiar with patterns, Greece, and I'm very interested by marine, and Greece has more than 9,000 island territories. About 200 are inhabited, as far as I know. I wonder to know if every island has a company for treatment, where the water is coming from to this island. Is there any link with if there is any fresh water coming from desalination or things like that, if you are aware of that, or if your company also work for these islands? So a lot of questions, but if you maybe can summarize, or I think it's interesting to know how you are managing in Greece all these islands and the problem of water, because they are beautiful, they are under the sun, but you need water, so that's a big problem.
Definitely. Thank you for the question. First of all, we are not in charge for water and wastewater management for these islands. My company is only in charge for the city of Athens and the surrounds. However, since there's a lot of things that happening in the water and wastewater sector, just a couple of months ago, there has been a new legislation national legislation in Greece that allows water and wastewater companies to merge, so that they can have better management and the economy of scale, actually, in everything. So what we believe is that the next months there will be a lot of merging, and things will be better for the islands. The islands at the moment mostly use desalination because they do not have enough water, and they have all these peaks in summer when demand goes very high, and then in winter goes very low, and vice versa. So they use desalination. They have a lot of desalination units in the islands, and there is also a thought of creating a kind of small reservoirs in each island that they can be filled with water brought from other areas of Greece that has water and store them in the winter to use it in the summer.
Okay, we have one question at the back there.
Yes, Jos Beels again. Thanks a lot. But I also am heavily engaged in the European Sediment Network, SETNet. And that brings me also to the topic of contamination associated to sediments, and which comes from the rivers downstream. First of all, to point out, 2-3 years ago, we came together with member states, experts, etc., to a guidance document how to deal with sediment quantity and quality in the Water Framework Directive context. So the document is there, explaining a lot of common sense how to deal with that. One of the key messages in the contamination chapter is that we have a lot of historic legacy on the floodplains, upstream, behind barriers in the reservoirs. So it's all mind about if there is a big flood, maybe take prevention measures that it's not coming downstream. If you're dredging your reservoir to increase the economic lifetime, make sure that you're not transporting contaminated sediment downstream. Can you agree to that?
I'm not sure who you're asking the question to. Maybe, if I can just clarify, so you're talking about reservoirs and contaminants in sediment, but on land, right? You're not talking about or maybe in floodplains, but not in the sea, so to speak. Yeah. But I think the question is, do we need to, should they make sure that when they dredge, for instance, that they actually make sure that they don't transport it down?
So, so the reason for that is that many contaminants are particle reactive. So they're heavily concentrated on particulate matter, especially on organic matter, and then they are stored in the sediments. And sediments are immobile if they stand there, but they can be active and bring contaminants back. This is a well-known thing in the science, and contaminants in the hinterland are also important, and also accumulation areas in the sea or in the coastal areas or in land-sea interaction areas. This is a risk, yes, of course. We have to keep that in mind, but we can avoid that. So this is natural. And if we change the water or the storms and the water cycle by climate change, we have these conflict and these problems. I agree on that.
Yeah. Can I follow on from your answer to ask Adriana as well about the pollutants in sediments, because I think that's your expertise, right? So how much do we know? Do we have enough science to actually be able to quantify that well? And how do we have a good understanding of how these pollutants in sediments sort of impact the health of soils? I know soil is quite a big thing in Europe these days. So yeah.
This is not exactly my expertise, but from what I know, I think we do have enough science.
Mm-hmm.
Sometimes the challenge is not necessarily to have the science, but to actually have the money, the infrastructure, and the policies to do what we need to do.
Yeah. Okay. We have another question. I'm not seeing a hand. Oh, it was Stefan. There we go. And then Kate afterwards. Yeah.
So my name is Stefan Fritz. I work for the German Marine Research Consortium. This is a question for all of you. And it follows on the last comment, but it's something that all of you have addressed. So the context is the European Union, the EU, has a European Institute of Innovation and Technology. It has an open call. The deadline is in the middle of June for a knowledge and innovation community on the topic of water. And it covers all aspects of water. So against the background of your presentations and your very different perspectives on the challenge, this call is to create a community that will receive effectively, to really keep it short, take public funds, mix it with private funds, and create investment tools and invest in, for example, the challenge we're talking about today. So, and the money that will be involved is quite substantial. It's the largest call on the topic of water that has been funded so far and probably will be for the next decade or so. So the question is, if you were to have an investment pot like that, and you're talking about potentially tens of millions of euros, where would you invest to create the maximum short-term benefit for society and medium-term benefit? So maybe technologies that don't yet exist, that haven't been implemented yet, or just procedures that haven't been implemented. So where would you make short-term investments? Where would you make medium-term investments from your different perspectives?
Excellent question. Who wants to go first? You're all going to have to think up an answer. So I'm not sure who's sacrificing themselves first. Excellent.
I think we need to invest more in education at all levels. I think this is something that we're not addressing enough. And we also need to invest more in a cohesive dialogue between society, policymakers, and scientists. We're doing that at a certain level, but maybe some things can be improved.
Okay. Detlef, did you?
I can add to that. I think I agree. So why do we throw plastic away in the environment? This is that we have to avoid. And if you have investment, I would invest in wastewater treatment. So this is the biggest source for nutrients and for organics. For trace metals, it's a little bit different. But for these two compounds, coming from agriculture or from human use, most of it goes through the wastewater treatment. And there is a place where we can invest and have a big impact.
You keep it there because I think they have to hear.
I agree with both suggestions. I already said adaptation strategies also for this erosion possibilities, like building green walls or also, yes, education. But beside education, there was a brainstorming session last week I participated, and there was a presentation about ocean literacy. And presenter said that just knowledge is not making a difference for people to act. You need to also act on emotional aspect. So maybe some advertising campaign. Just not to act only on their fear, but also like our love for the sea and importance of the sea. And from my research side, I was working a lot on monitoring tools like DGTs. And so this is for me, what I would like to do. So monitoring strategies and new tools.
Thank you.
It should be on. Yeah.
Okay, great. So in short term, I would invest in water reuse, as I said before. But in long term, I'm thinking a little bit differently. I mean, we create a problem, which is the pollutants, and then we try to solve it by new treatment ways that create other problems, which is more energy consumption, more consumables, membranes are consumables, chemicals are consumables, which means more waste. And then in a few years, there will be other emerging pollutants that would need another way of treatment, and this will never end. For me, we have to stop the problem in the beginning, and the problem is over-consuming. So we have to reduce over-consuming of plastic, of PFAS, of anything that contains PFAS, and there's a lot of things, overconsuming of pharmaceuticals, as very well been said before, in order to stop having so much volume and concentration of these pollutants, micropollutants. So I would invest to policies that would actually go to this. So stop using all these materials and educate people to avoid them and make them understand why.
That's it. Very good. I think we have Kate and then you, Louis. Yeah.
Thank you very much. Kate Larkin, representing the European Marine Observation and Data Network, EMODNET, which is the in-situ marine data service of the European Commission. So my comment is more an invitation, if you like. So EMODNET, as you may already know, has a lot of marine knowledge on offer from the marine, but also coastal marine data, and increasingly the land-sea interface. And we're working closely with projects like Lancelot that Jos is coordinating to see how we can expand and evolve the EMODNET service to offer more of this coastal data. So firstly, it's an invitation for the coastal and land-based research infrastructures such as Adriana's representation of Danubius to see how we can work more together and bring more data together. But then I have a sort of direct question for all of you to see how could we move forwards to connect this quite mature marine knowledge with the existing mature capabilities of more freshwater or land-based terrestrial knowledge. You know, in the marine domain, we have worked over a decade and more to bring together EMODNET, Copernicus, and now we have the European Digital Twin. So we have, you know, big assets of marine knowledge, we have interoperable data, and we're now at the point where we can really interface a lot more with the land-sea interface with freshwater domains as well. So it'd be really interesting to know your comments on how we could move forward to really start connecting the marine and freshwater data spaces or marine, you know, different knowledge areas.
I don't know who want to answer, and while you're thinking of your answers, I will mention that the remediation project that I mentioned at the beginning that was also mentioned here actually is specifically feeding in their data to EMODNET already. So I think there's a push already from the EU project perspective, but I don't know if anybody else wants to tackle that very difficult question. Detlef looks like he's yeah.
Maybe just a comment, or I'm not from this group of sciences, but I know we have a lot of data banks in the marine area, HELCOM and OSPAR and ICES and whatever, and also in the terrestrial or in the water system from terrestrial areas. We have to bring these communities together. This is the way. I think we have enough capability in the data banks, and all the data we produce are going into the data banks. But yeah, we have to bring these communities together.
Yeah, I think the question is how to do that. And maybe it needs to be done at that level. If all the data, if all the terrestrial data is feeding into it and freshwater data is feeding in there, then maybe it kind of needs to happen at the higher level. Does anybody else want to have a go? Otherwise, we can go to the next question.
Thank you. Louis Cellier from Gerix in Germany. I would like to push back a little bit on the suggestion that the solution lies in the consumer changing their behavior, because it's not that simple. The old system that we have of consumption pushes the consumer to do what needs to be done to live. So where does regulation come in? Where does investment in a circular economy come in, that we value the things that we consume enough that they go back into circulation? So why come the solution in this case lies with the consumer? I don't think that's even a part of it's a small part of the solution, but we need at least stronger regulation. We need more monitoring of industry. We need more incentives or disincentives for creating pollutants and litter. So do you have any thoughts on how to distribute the roles and responsibilities a bit more fairly or equally in the value chain in which all of these pollutants and waste are produced?
I'm not 100% sure if the people on the panel actually have the expertise to answer that, but if anybody wants to have a go. I mean, I think it is indeed that regulation is really important. I don't think it's I don't think you can't just do one or the other. So I think you definitely need to do both.
Yeah, I just want to say I agree that it goes from consumer. So maybe not starting with regulations, but with again advertising, changing their way of thinking and what is in fashion. Like I know, like veganism is in fashion. So produce them wanting to do better, like in this way, and that can be better way to also influence policies, and so maybe from different direction to influence demand.
Yeah, and maybe to say that really in the 7 years that I've been doing this job, I realized that the way to change regulation is actually through people as well, because it's not going to happen if you don't convince the politicians, and the way to convince the politicians is to convince the people. So maybe if people don't realize that there's a problem, they won't speak to their politicians, and then nothing will change. So maybe not really a good answer. We have a question there. Reminder to please say who you are.
Okay, thank you. My name is Aurore Troutet. I work for IMDC. We are a Belgian consulting company. I'm a scientist, but I moved to the consulting part. All the discussion is super interesting. You mentioned that we can monitor a lot of things. We need to focus now on the new ones, but I would like to focus on, for example, PFAS and microplastic. For PFAS, there are thousands of PFAS. They are used on daily basis. They are everywhere in the water, in the sediment. And because we work on that and we discuss also with governmental agencies and also private sector, thresholds. Like, okay, we need to act on this. We want to reduce this, but it seems that also between the monitoring and regulations, the guidelines, so you need to define threshold, and relevant threshold to be sure that okay, you need to push a regulation and a private company to monitor, but you're the one, you're scientists, we need us or you guys to define this threshold and relevant threshold to delimit, okay, what is the maximum level that should be released by an industry and all of this. And with PFAS, we really feel that there's a huge gap and huge difficulties. So, and also, where are the data? Because we always we look for data. PFAS, it's quite expensive still to monitor PFAS. My question is how we move forward with the capability to monitor them, to really go in taking action and supporting also regulation to provide really the rules and or the support to really move forward and reduce this one.
Yeah, that's a really good question. I think thresholds and the fact that there's so many, chemicals out there that we don't know hardly anything about. So, when you have a regulation, you need to have a threshold. Otherwise, it's just a law for the sake of law without actually being able to monitor it properly. So I don't know if anybody wants to. Detlef, you seem to be ready.
Personally, for me, the threshold is 0. So it shouldn't be there. So it's all anthropogenic. It's not natural. So 0. But what is the threshold good for? It's one thing is we define the threshold by the analytical method. That is, if 10% of the, or if 90% of the measuring institutes can measure it, they define a threshold here. It doesn't matter that this is really from a toxicology point of view or from the point of the ecosystem, a good value. So it's really hard to find. And for a complex mixture like PFOS, it will never be possible to define a threshold. You can define a threshold for individual compound, but not for the complex mixture we have in the environment. It's not possible. It's a dream.
But for instance, thresholds or toxicological thresholds for things like PCBs and things like that have those have been established, right? So
yes, for an individual, if you test an individual PCB, you can give a threshold. But if you have a mixture, you can't say that this is the right value. So there is a risk behind. You can say, okay, this is an area where we have lower and higher concentrations, and we accept the lowest concentrations we found, and all the rest is to do something. It's another way. But from a scientific view, from point of toxicology, threshold is nonsense.
But there is there's a scientific LC50 or something measurement for chemicals, right? And is that not a first step for saying, okay, this, this level is the level by which the LC50 means 50% of the animals will die if they have that level. So that would be, for me, not being a chemist, be the level that I would say, this is what,
Well, this is a way you can make it practical. Of course, you can have an individual compound say, okay, if the concentrations is higher than this, you have 50% die of some algae or organism. It's okay. But if you have a long-term impact, if you look at the complex mixture you find in the environment, you don't know.
Yeah. So certainly you can sort of set some sort of level per each one, but
the risk of
yeah. And then you put climate change on top of it, where things and all the other impacts that species have in the environment, and then it becomes more difficult. Yeah, you have to. Do we have an online question? Oh, you have a question. Oh my goodness. It's allowed. It's totally allowed.
Yeah, I'm Paula Kellett from the European Marine Board Secretariat, and I'm asking my own question. So I was actually really interested in, you showed the huge amount of technology that's required to trace all these different things that you already test for. And I think we can all agree this is only going to get worse as we keep trying to find different pollutants, different chemicals, different compounds. So it's kind of a question to all of you, but are we going towards everyone needing more and more technologies? Are we moving towards people needing to share these types of infrastructures? Are there solutions in the machine learning and digital space to address these problems? What are we looking for, and how bad is it going to get if we really try and trace as many pollutants as possible?
And maybe following on from that question, if you had, like Stefan was mentioning, some investment, do you think there would be better machines that could do it better if you actually had good investment? If you're not just building this up, one step at a time, but could we think of a overall amazing machine that could measure it all? Or am I just making this up now?
Of course, this is an ongoing process, but is that money consuming, a lot of money, and what is the impact? So a better impact is to reduce the contaminants in the environment and the input. And this is what I meant if I say stop at the beginning.
But maybe I will follow that question if nobody else.
Technique will go on. Also, analytical technique will go on. It will be more and more expensive, of course.
I was going to follow on that question with a question sort of based on the Danubius, and the Black Sea in general, because given that Europe doesn't live in a vacuum. You know, for instance, in the Black Sea, in the Mediterranean Sea, half of the people are not following our rules or any rules in some cases. So how would we be able to then ensure that we have good environmental status, for instance, if we don't, if we have no ability to stop the people outside of our borders from polluting?
Everything is money driven. Must be expensive to bring these contaminants in the environment, from industry or from agriculture or from the private person. This is, and it's teaching people not to do that.
Anybody else want to have a go? Otherwise, we can go to Cosimo.
Yeah, I'll just briefly answer your question. So the idea in Danubius to have a distributed research infrastructure is actually not to have to develop the same kind of technology everywhere in like 30 countries or so. So taking the best that every country has to offer and doing this as a common effort. Regarding your question, I'm thinking more and more from a scientific point of view, but also as a citizen, that sometimes the problem is that we create the problem and then we put all this effort to resolve the problem that we create, spending more money instead of, okay, we understand that we are maybe the problem, people in the environment, and that we have to start with us, with what we think we want to live or how we think we want to live. I see a lot of people who aspire to this kind of life that they think it's ideal. I don't know, living in a big city and running around like crazy. And it's a type of life that doesn't allow you to, I don't know, you have to grab a plastic bottle because it's easier, because you don't have enough time to filter your own water or find something that's more sustainable. And maybe we should actually think more about the way we live and the changes that we can make right away. Thank you.
Okay. I think we had Cosimo. Did you also have a question? We'll have Cosimo, Torsten, and then your comment.
Yeah.
And then I think we'll be done.
Cosimo again. And I totally agree, of course, that's important to educate people and final customers in order to, final consumers in order to reduce the impact. Still, I don't think that it's totally fair to just ask the normal people to bear the load of this transformation. Wouldn't you think that maybe it's important also to ask to big industry to change their production line? I mean, if you think in terms of life cycle assessment, there are different ways to produce something, and some production chain is more environmental friendly, is more easy to recycle everything you produce, and so on and so forth. Maybe we can ask pharmaceutical industry to target molecules that are more friendly from an environmental perspective, that produce less poisons, less that decay metabolites that are not so dangerous for the environment. I mean, we can ask quite a lot, I would say, to this big industry that make quite a lot of money, rather than say that it's just a problem of our final consumer, because we have to bear our share of responsibility. But I think that it's a very clear and political idea, no? That you want to move the burden of this, the cost of these transformative changes from big industry to normal people. And I think that this is not fair. Normal people should do their share, but that's just one of the side of the coin.
Does anybody want to?
Yeah. So this to happen, it could be two ways. I mean, both ways are bringing more money. So first way is again societal pressure or advertisement, we are clean, or like the new way being cheaper to produce. So I don't see any other way. And again, this is going from society to industry. Again, one of the possibilities, like creating new demand.
I don't know who had a question. You had a question or Torsten had a question? Oh, Detlef's going to answer still. Yeah.
There are REACH, the REACH system that the industry has to make some tests what the new chemicals, if they are entering the environment, what the impact is. There is a good thing in the industry on that way, I think. But if you ban, for instance, glyphosate, they will produce another herbicide. We didn't know what's going on with that in the environment. We need 10 years of research to see, oh, this is, again, it's another problem, but it's a problem. And what to do then? So it's really, really difficult.
Yeah.
Unless the agriculture and the humans are looking for these products, they will produce them.
Yeah.
And they are not producing something to contaminate the environment. I think they producing to get money out of that. Yeah, that's life.
Yeah, I was also not sure that we necessarily would have the ability to say this molecule would necessarily be better for the environment than this one until we've actually tested it, right? Very hard to do because these things take a long time. So you have a question, Angel?
Hi, I'm Angel Mir from the European Marine Board Secretariat. And I see also many of the comments is really related to the keynote this morning, like, to rethink about our relation with nature and like why compounds are thrown away instead of like be reused. And it's also what to highlight that the revision of the urban wastewater treatment directive, there is also they added, at least for some compounds, that the polluter pay principle. So indeed to start thinking that instead of like companies throwing away their products or for instance, for pharmaceuticals and so on, that to already start thinking that, okay, what could be the potential impacts on the environment? So I think regulation is starting to treat with that, but indeed, it's not maybe as fast as we will like to be. But I think there is efforts on doing that, but indeed, it's always the devil in the details. It's like how you implement it, how you implement it well. And then, of course, with all the things like 6 years to revise and so on. So yeah, but this is starting.
Yeah, I think the polluter pays principle should for sure be in there because it seems to make sense. Torsten, did you still have a cost question? And then I wasn't sure if there was somebody else, but then I think we can wrap up after that. Oh, yes, we should wrap up.
Good. Torsten Kiefer from JPI Oceans. So the question is to Saša, Detlef, and Adriana. Basically, the question will be, is the monitoring good enough of chemical pollution, whether organic or inorganic, that we would even see that we make progress or the opposite of progress? And because then whether it's now societal change of behavior and so on, or whether it's regulation and so on, I think the main motivator and a kind of a precondition for addressing the problem of pollution is that we can actually measure it. So, okay, so the question off the coast of Croatia, off the coast of Romania, the coast in the Baltic Sea, would we even see it?
So yeah, I'm so critical today. So I would answer the monitoring is not okay. Why? So in the monitoring, we concentrate on the POPs, for the organics, on the Stockholm Convention banned chemicals. We know about them. We know they are persistent. We know they are produced not anymore. And still we're measuring it in the monitoring program and spend a lot of money to do that. And all the new things, we don't know much about it, only research, not from the monitoring. PFAS, we don't have a PFAS monitoring. And I know for 10 years that we need a PFAS monitoring. But still, the countries say we have to look for the POPs, the dioxins. We still measure dioxins. Crazy. What technique we need to measure the dioxins? And we can't change the concentration anymore by no technique. They are still there. They may be there, PCBs, for the next 100 years. We have to accept that it was a mistake in the past, but we have to concentrate on what is going on now. The new pesticides, the medicine, and yeah, PFAS, for instance. And we have to change the monitoring. This is my criticism on the monitoring, is that we try to keep it unlimited. And then we try to add new compounds. And then we say, oh, this is very costly and we can't do it. And we have to stay with the old things. And this monitoring must be flexible.
Okay, do you guys want to also, if you want to answer that question or give a wrap up? I think we are eating into our lunch now and my stomach is telling me that it's definitely lunchtime. So you have a quick round if you want to add anything more to your comments. No? I think we can summarize that we need more monitoring and we need more research. I think that was a good summary. So I want to thank the panel very much. It was great. And we will have a lunch now for, I think, an hour and a half, if I'm not mistaken. And we will be back at 2:30 for the people online. Enjoy your lunch. And for the people in the room, I think we're going back to the dinosaurs to go and have our lunch. So thank you very much, everybody.